Hi there and welcome to another video for the linear AQA GCSE higher maths paper. This is practice paper 2 set and it is the calculator version. It should take 2 hours but we should be able to do it in an hour. Right, first question. Work out the value of the following. Give your answer to one decimal place. The trick with these is to make sure you work out the top first and the bottom and then you divide them. If you do anything else, you're probably going to make a mistake unless if you use brackets on your calculator. So I would do 3.11 times 8.76 and on top that is 27.2436 and on bottom 4.23 take away 2.71 is equal to 1.52. If you divide these two numbers by each other you get yourself 17.92, which is 17.9 to one decimal place. Don't not get any marks here for not rounding to 1dp or making a mistake on your calculator. That would be an absolute travesty. Question 2. Danielle tosses a coin and rolls a dice. If the coin shows head, the score is 3 times the number on the dice. If the coin shows tails, the score is the square of the number on the dice. Show that there is a 50% chance of a score more than 10. Okay, so let's list all the possible outcomes. If she gets a head or a tail, and then the scores on the dice, if she rolls, is either 1, 2, 3, 4, 5, or 6. Okay, now if she scores a head, the score is 3 times the number on the dice. So if she gets a head and a 1, she'll score 3, 6, 9, 12, 15, and 18. If she scores a tails, the score is the square of the number on the dice. So it would be the square of 1, which is 1, 4, 9, 16, 25, and 36. Show that there is a 50% chance of a score more than 10. So the probability score bigger than 10, it's got to be bigger than 10. It would be this one, this one, this one, this one, this one, this one. It would be 6 out of 12, which is a half, which is the same thing as 50%. Really straightforward. If you just list out your outcomes in a two-way table, everything suddenly becomes very straightforward. If you try and list them out in lists, I think it's going to be difficult for you. Do a two-way table or a sample space table and it's very straightforward. Question 3. ABC is a triangle. Show that ABC is isosceles. For it to be isosceles, this angle, this side and this side must be the same, or this angle must be the same as this angle. So let's firstly work out x from here. We know that angles around a point add to 360 degrees. Okay, so therefore x plus x is 3x, plus 5x is 8x, plus 80. So 8x plus 80 must be equal to 360. Let's solve for x. Take away 80 off both sides. 8x therefore must be equal to 280. And therefore x must be 35. Okay, so if this is therefore 35 degrees, okay, then this angle here, which I'm going to call y for now, I don't know it's the same, I've got to show it's the same. Y is therefore 180, subtract 110, subtract 35, which is 35. So this angle here is 35 degrees, therefore isosceles. Okay, so and then we're done. Question 4. Mark wants to book a holiday for 2 adults and 1 child. He sees this advert. He has £800. Can he afford to book the holiday? Tick yes or no, show you're working. Right, so he wants to book for 2 adults and 1 child. So, 2 adults would equal 2 times this, which is £680. 1 child, well that's 250. If you add those together, you get yourself £930. But you've got a 15% discount, so discounted price would be 0.85, that's a percentage multiplied to reduce something by 15%, times 930, which would be 0.85 times 930, which would be equal to 900 £790.50p. Do remember to write 50 like that. So can he afford? Yes, he can afford, and just leave it like that. Some students don't like using percentage multipliers. Remember, a percentage multiplier, if you want to increase something by 10%, you multiply by 1.10. If you want to increase something by, let's say, 23%, multiply by that. If you want to decrease by 10%, you multiply by 0.90. And if you want to decrease by 23%, you multiply by 0.77. They're percentage multipliers. Equivalently, you could work out 15% of this and subtract it from 930. I just think this is way easier. 4b, Mark exchanges £400 to euros. The exchange rate, £1 is 1.15 euros. He comes back to the UK with 105.80 euros. What percentage of the 400 did he spend? So again, 4 marks here, and just lay out your work in nice and simply. So euros he had. Euros originally would have been 400 multiplied by 1.15, which is 460 euros. He comes back with 105.8. So he spent, how much did he spend? Well, he spent the 460 he went with, take away the 105.8 he's left with. So he spent €352.20. What percentage of the £400 did he spend? Well, if you want to work out the percentage spent, it's how much he spent, which is 354.20, over how much he had originally. Now, don't do over 400 here, whatever you do, because they've got to be in the same units, haven't they? So over, originally he had 460 euros, and you multiply that by 100. If you do that, that will give you your percentage, which is 77%. Whatever you do here, just here's a warning for you, do not divide here by 400. Do not divide by 400, as that is the pounds number. You want how much he spent in euros divided by how much he had in euros. Or you could have converted them both to pounds, but it's easier to keep it in euros. Okay, a diagram shows a regular pentagon. That means all the angles are the same. That means that's x, the whole lot's x, that's x, and the whole lot here would be x as well. Work out the size of angle x. Well, you know that inside a pentagon, there are two ways of doing this actually. Firstly, it's a regular pentagon, so you pick one side, draw lines to all the other corners, and you've got yourself 1, 2, 3 triangles. So the interiors add to 3 times 180, because there's 3 triangles, which is 540. And if each one's the same, because it's regular, 540 divided by 5 would be equal to 108 degrees. So the answer is 108 degrees. Okay, that's one way of doing it. The other way of doing it, I'm just going to rub this out for now. The other way of doing it is to know that the exterior angles, whatever this is, the exterior, all of the exteriors add to 360. Okay, so you could state that the exteriors add to 360. So one exterior is equal to 360 divided by 5, which is 72 degrees. So if this here is let's say 72 degrees, then x must be 180, take away 72 degrees, which is 108 degrees again. Now, work out the size of angle y. Now, if you look at this here, if you now know that this here is 108 degrees, and you know this shape is regular, so all the sides are the same, this is an isosceles triangle, okay? So you could work out that angle there, let's call that z. So z must be equal to 180, subtract 108, divided by 2 for each one, and that'd be 36 degrees. And if you know that's 36, and the whole of that was 108, therefore y must be equal to 108, subtract 36, which is equal to 72. And you're done. Question 6. Amy wants to know how often people in the village go out for a meal. She writes a question. How many times do you go out for a meal? Just reading that before you read the question. If you were asked how many times do you go out for a meal, you would say, well, what, in a week, in a month, in a year, in a decade? So there is no time frame. Okay? Also, never 1 or 2, 3, more than 4. So a criticism of Amy's question is that there is no time frame. A criticism is that there is no time frame, as I said before. What is one criticism of Amy's response section? Well, look, it's either never, 1 or 2, 3, or more than 4. So surely 4 needs to be an option. So there is no box for 4. What if you went out 4 times a week? Which would you tick? The 3 box or the more than 4? So that is a problem with her suggestions there. Okay, next. 7. Here are some results of a survey of how much 60 people pay for their meal. Draw a frequency polygon. Now remember a frequency polygon. We've done this before. The way I did this the first time to show you, between 0 and 10 it's got a frequency of 70. So I drew a box between 0 and 10, a frequency, of 7. Okay, between 10 and 20 is 19. Between 20 and 30 is 24. And between 30 and 40 is 10. Now, it wasn't a bar chart they asked for. It asked for a frequency polygon. It's the midpoints of these bars joined up together. That's what a frequency polygon is, as follows. Okay, and really, you shouldn't need the bars there at all. Okay, it should just look something like this. Now, how would you do that without the bars? Well, let's just rob this whole thing out and just do it without the bars. All you do for a frequency polygon is the midpoint of the interval you plot against the frequency. So plot 5 against 7, so 5 across against 7. Okay, 15 against 19, so 15 against 19. 25 against 24, 25 against 24, and 35 against 10, so 35 against 10, and then draw a line between each of these. So there's no real need for bars. A frequency polygon is as follows. What proportion of the 60 people spend more than £20 on a meal? So go back here. What proportion spend more than £20? Well, more than £20 are all these people here, because they're bigger than 20, less than 30, or bigger than 30, less than 40. So in total, it's 34 out of 60. So the answer for this one is simply 34 out of 60, and you could simplify your fraction if you wanted to. If you tap that in your calculator, 34 out of 60, it's 17 out of 30, or 17 out of 30. That is a proportion, a fraction. Okay, reflect A in the line y is 5. Firstly, draw your mirror line. Y equals 5. All the points where y is 5s, for example 0, 5, 1, 5, 2, 5, it, with a bit of thought, it's just that line there. And you want to reflect that in that shape, so this corner stays where it is. This corner is 1, 2, 3, 4 away, so 1, 2, 3, 4 away. And this corner is 1, 2, 3, 4 away, so 4 away again. And it's a reflection, so it's simply this. Very, very easy there for 2 marks. Describe fully the single transformation, okay, the one transformation that gets you from shape B to shape C. So you're going to start here and you're going to end here. How do you get there? Well, firstly, let's write down our possible transformations. What transformations, just as a bit of revision. The first one is a translation. That's simply where you move a shape. So a shape like a triangle would just get moved around the page. It's not that because it's not the same way up, as it were. Okay, so it can't be that. The second type is an enlargement, where you make it bigger or smaller. So something like this would go to something like this. Okay, it's not that. They're the same size. The next one is a reflection. So that's when you have a shape and you reflect it in a mirror line. And the last one is a rotation, and that's some sort of twist. So you have a shape and you twist it around the center point and it would move somewhere over here. Now, from these two, clearly it's either a reflection or a rotation, because is it some form of twist or is it some form of reflection? Now, hopefully you could see, if I drew the line y equals, if I drew that line there, the line y equals x, and you just look at it sideways on, you can clearly see that so we've got here a reflection in line y is equal to x, and we're done. Okay, question 9. Dan runs 15 marathons. Here is a summary of his times. One marathon he got between 200 minutes and 220. 5 marathons he got between this and that. Ella also runs 15 marathons. Her mean time is 4 hours 17 minutes. Dan says on average he's faster. Is he correct? What we're basically being asked to do here is work out the mean of Dan's marathon runs, compare it to Ella's, and see who's quicker. Now, the mean here, you know that one person got anywhere between 200 and 220 minutes. And you know, one time he got between 200 and 220, 5 times he got between 220 and 240. If you want to work out an average, you need a number that reflects as best as possible that group. So you use the midpoint. So that's why there are 2 columns. The midpoint here would be 210. The midpoint here would be 230. The midpoint here would be 250. The midpoint here would be 270. And the midpoint here would be 290. So you've got, firstly, you'd like to work out the total number of marathons. It's the sum of these, and it was given in the question, it's 15. Now, to work out the mean, you want the total time he took divided by the total number of marathons he did. So the total time he took, well, one time he got a midpoint of 210. So you multiply these and get 210. 5 times he got 230, or that's our guess at what he got. So you do 5 times 230, which is 1150. Next one you do 6 times 250, which is 1500. Next you do 2 times 270, and it's 540. And last you do 1 times 290, and it's 290. You add these up, and you get 3690. So his mean for Dan is 3690 divided by the 15 marathons. So it's 246 minutes. That's an approximation. Now her mean is 4 hours 17. So let's convert this to hours. 60 minutes an hour. So therefore this is 4 hours and 6 minutes left over. So that's 4 hours and 6 minutes. Her mean is 4 hours 17. Therefore Dan appears correct. Appears correct. Correct. As his mean is 11 minutes less. So therefore he must have been quicker. Okay, next question. A and B are on the line y is equal to x. The midpoint of AB has coordinates 4, 4. The x coordinate of B is 3 times the x coordinate of A. Work out the coordinates of A and B. Simple to just draw a picture. Okay, let's not try and overcomplicate this. Let's just draw a picture. Here's the line y is equal to x. Okay, here's the x-axis, here's the y-axis, here's y is equal to x. We know that AB has coordinates 4, 4. So the midpoint of AB has coordinates 4, 4. We know that the x-coordinate of B is 3 times the x-coordinate of A. So therefore, let's say the x coordinate here, let's just call this point here A. Okay, if this is xy, or it's given that it's on the line y equals x, it would be xx, wouldn't it? Because it would have the same coordinates. So A, if that was xx, we know that the x coordinate of B is 3 times the x coordinate of A. So B, okay, must be 3x, mustn't it? And we're asked, work out the coordinates of A and B. Well, it's simple really. All you've got to do is, to work out the midpoint, you add the coordinates up and divide by 2. So x plus 3x, if you add that coordinate and halve it, which would be 4x divided by 2, which is 2x, that should give you this number here, and which would be 4. So x therefore must be 2. Therefore this coordinate of A must be 2, 2, and this coordinate is 3x, 3x, which is 6, 6. If you add these up and divide by 2, you get 4. If you add these up and divide by 2, you get 4. You could have probably got that yourself as well, just by trial and error. Okay, next question. Here is a formula to convert Fahrenheit to Celsius. This is about temperature, so you can convert Fahrenheit to Celsius. Okay? Now, Maria telephones her friend, Jenny in Spain, and Maria says the temperature here is 78 Fahrenheit. Jenny says it's warmer here because the temperature is 25 degrees Celsius. Is Jenny correct? Show you're working. Okay, well, why don't we, let's say, we know that Maria saying it's 78 Fahrenheit, right? But Jenny's saying it's 25 Celsius, so couldn't we just substitute 25 in here and work out the equivalent Fahrenheit? So Jenny's Fahrenheit temperature must be 9/5 multiplied by 25 plus 32. Now you could just type that straight in your calculator. 9/5 times 25 plus 32, it would be equal to 77 degrees Fahrenheit. So Jenny says it's warmer here because the temperature is 25 degrees. Is Jenny correct? Well, no, Jenny's not correct. It is colder by 1 degree Fahrenheit because Maria's temperature is 78, Jenny's temperature is 77. Jenny is not correct at saying it's warmer here because it's 25. Okay, and we're done in that regard. 11 part B. The graph shows the temperature of a water bottle in a freezer. It starts off at about 55, and it goes down to just under 30, and it takes 140 minutes to do that. Water starts to freeze at 0 degrees Celsius. How long does it take for the water to start freezing? Well, water freezes at 0 degrees Celsius. This temperature here is in Fahrenheit. So we need to go back to our previous one where F is equal to 9/5 Celsius plus 32. Now we know water starts to freeze at 0 Celsius. That is the same thing as 32 Fahrenheit, because if we substitute in 0 here, it's the same thing as 32 Fahrenheit. Okay, so we want to make sure we draw a line on a graph. We want to read across from 32. Each one of these must be 2 units. So you draw a line across from 32 and then a line down. It looks to me that it's approximately, let's just go, my line's a bit thick there really. It's approximately 80, I think. It's about 80 minutes. So therefore 80 minutes is your correct answer. Do state this working here. This 32 gets you 1 mark, and reading off your graph with a line gets you the second. Okay, solve the following equation. Firstly, all numbers onto one side. Add 2 to both sides. You get 0.7a is equal to 0.2a plus 5. Then subtract 0.2a off both sides, and you get 0.5a is equal to 5. Then divide both sides by half. Dividing by half is the same as doubling it. A must be 10, therefore. Okay, now, if you say got that last line confused and halved it and got 2.5 say, you should still check by substituting in. Let's check we get the right answer with A is 10. 0.7 times 10 is 7, 7 take away 2 is 5. 0.2 times 10 is 2, 2 plus 3 is 5. We know we've got the right answer, always double check. Expand the following, 4b and then subtract 4 times 2. So it's 4b subtract a. Do not write 4b take away 2. That is a travesty of a mark to lose there. When you multiply it, you multiply each term. Simplify the following. We're multiplying here. So we've got 2. I'll just tell you the answer straight away and then I'll show you 2 ways of remembering it. Just do the numbers. There's a 2 here and there's a hidden 1 here. And 2 times 1 is 2. C squared times c to the 4 is c to the 6. And d cubed times d to the 2 is d to the 5. That is your answer. Because you are using the law that multiplying indices, you add the powers. Now, if you're confused that is it you add the powers and times the powers, just write this out and what it means. Look, it means 2 times c times d times d times d. And this is times c times c times c times c and times d times d. Okay? Now, you've only got one number there, 2, hence 2. You've got 1, 2, 3, 4, 5, 6 c's multiplying together, so it's c to the power of 6. And then you've got 1, 2, 3, 4, 5 d's multiplying together, so it's d to the power of 5. Okay? So, you know, when you're going through indices questions, and there's a lot of rules to remember, just try and think logically, and that will always help you get the right answer. Factorise fully the following. Now, 2 marks here is because there's a mistake that some students make here. Firstly, deal with the numbers. What's the biggest number that goes into 4 and 6? Well, 2. Then deal with the algebra. What goes into x squared and xy? Well, x does. And, open your brackets up, 4x squared divided by 2x is 2x left over, plus, from here, 6xy divided by 2x just gives you 3y. And then double check you did the right thing by multiplying out. Again, 2x times 2x is 4x squared, 2x times 3y is 6xy. Got it. Okay. Fully, when it says fully, it means there is a number to factorise and some algebra. Okay, simplify the following. C to the half to the 0.6. Right. Now, again, there is a rule to remember here. If you have an indice to a power to another power, you multiply the powers as so. Okay, for example, 2 to the power of 3 to the power of 4 is 2 to the power of 12. That's one way of remembering it. The other way of remembering, if you're stuck here, so the answer to this should be 6 to the 0.5, c to the 0.5 times 6, which is c to the 3. Now, if you're stuck at remembering these rules, just think what this means. This means c to the 0.5 times c to the 0.5 times c to the 0.5 6 times, right? Okay, now you know that when you multiply powers, you add the powers. So this would be c to the 1, c to the 1, c to the 1, and therefore it would be c to the 3. Okay, so remember your rules or just think logically. Okay, A, B, C and D, E, F are similar. Very important word there. That means one's an enlargement of the other. Work out the value of x. We want to know this value. Now these two are linked. So the scale factor, we can work that out by doing 50 divided by 20 and it will give us 2.5 as the scale factor. Therefore, how do I get from the smaller one to the bigger one? Well, I multiply by the scale factor 2.5. So therefore, if I want to work out x, x is 16 multiplied by 2.5 and it's simply 40. Okay, so the answer here is 40. Don't forget your units, centimetres. Easy 3 marks. Question 14. A light is fixed on horizontal ground, 25 metres away from a vertical wall. The height of the wall is 20 metres. When the light is switched on, the beam just clears the top of the wall. Work out the angle here. We've got a right angle triangle. It's Pythagoras or SOHCAHTOA. We want to find angles. It must be SOHCAHTOA. Write down so TOA. Okay, this is the angle we want to work out. Let's label the triangle with reference to this angle. This is the opposite, this is the adjacent. Don't bother labeling that. We just want to label the ones we either want to find or we have got. So what has O and A? TOA. Write down what TOA means. It means tan of your angle, which is x in this case, is opposite divided by adjacent. So tan of your angle, keep writing tan of your angle is equal to 20 over 25. Therefore your angle is the inverse tan of 20 over 25. Your calculator must be in degrees mode, so the inverse tan of 20 over 25, and you get 38.6 degrees, 0.7 degrees. Both your answers were to 2 SF, so I'd probably just say 39 degrees to 2 significant figures. Okay, and double check, does that seem reasonable? If you got an answer like 140, it would be rubbish. Does that seem reasonable? Yeah, 30 degrees, 39 degrees, that's about right. Because remember, if it was 45 degrees, yeah, 45 exactly cuts 90 in half. If it's 45, whatever length this is, if this was 25, this would be 25. So slightly less than that, 25 and 20, that sounds about right at 39 degrees. Okay, solve the following inequality. Remember, just treat inequalities like equal signs. Do the same thing as you would normally. Let's add 7 to both sides to remove that, subtract 7. So you get 5n is less than 3n plus 23. Okay, then subtract the 3n off both sides to get the n together. 2n is less than 23. And then divide both sides by 2. N is less than 23 over 2, which is 11.5. N less than 11.5 is your answer. Not n equals 11.5. Keep the inequality in with the final answer. Question 16. A football crowd has 27,000 adults and 5,000 children. A stratified sample of adults and children of size 40 needs to be taken. Work out the number of adults and children in the sample. So, the total crowd must be 27,000 plus 5,000, which is 32,000, right? And you want to take 40. So your sampling fraction, what percentage are you sampling? Well, it's how many you sample, 40, out of the total 32,000. Tap that in your calculator. 40 over 32,000 is 1 over 800. That's your sampling fraction. You want to sample 1 in every 800 people. Now, there are this many adults, this many children. You want to do the right ratios. So you do 27,000. You want to sample 1 in every 800 of them. So you multiply by that. And you get yourself 33.75. You do the same thing with 5,000. 5,000 times 1 over 800. And you get yourself 6.25. This one you round up. This one you round down. And therefore it would be 34 adults and 6 children. And that adds up to the 40 sample you need. And that's a representative sample. Okay, complete the table of values for the following function. 4 subtract x cubed. So let's just think how they got the answers they did with 0. 4 subtract 0 cubed is 4 subtract 0, which is 4. 4 subtract 1 cubed is 4 subtract 1 cubed is 4 subtract 1, which is 3. Let's put in negative 2. Negative 2 cubed, if we were doing 4 subtract negative 2 cubed, well, negative 2 times negative 2 times negative 2 is equal to negative 8. And 4 subtract negative 8 would be 4 plus 8, which would be 12. That's where they got the 12. So let's do the same very carefully with 1. We're doing 4 subtract negative 1 cubed. Very important you substitute into brackets. Negative 1 cubed is negative 1 times negative 1 times negative 1, which is negative 1. So 4 subtract negative 1, which is 4 plus 1, which will be 5. And let's do it with 2. 4 subtract 2 cubed. Well, 2 cubed is 8, so 4 subtract 8, which is negative 4. And they are your answers for for 17 part A. And you're asked to plot this graph between -2 and 2. So for -2 you get 12, so for x is -2 you get 12, across there. For x is -1 you get 5, x is -1 you get 5, which is there. For x is 0 you get 4, x is 0 you get 4, x is 1 you get 3, and x is 2 you get -4. So it looks something like that there, okay? Use your graph to solve 4 minus x cubed is equal to 0. Remember, you've drawn y is equal to 4 minus x cubed, the graph, and you're trying to solve this equals 0, so you're trying to solve where y is 0. Where on the graph is the y number 0? Well, it's 0 about here, isn't it? That's where y is equal to 0, and it looks like the x value that works for that is about x is 1.6. X is 1.6 approximately works for that, so x is equal to 1.6. Okay? Now, if you're in the exam and you're not sure what to do, you could solve for subtract x cubed is 0, add x cubed to both sides, and take cube roots. So x would be the cube root of 4. Which is actually 1.58. So you know the answer is 1.6 roughly. This would be your sort of scrapple of paperwork. And you look back here and you think, when is x 1.6 or 1.58 important? Here. And you realise that this is the point that you're supposed to highlight on your graph. And then when you do that, say C graph, to show them that you have found what's called the root. The root is when y is equal to 0. It's the x number that makes the graph y equals 0. Okay, some circle theorems. Work out the size of angle x. You should know your circle theorems. This is a cyclic quadrilateral. It's a four-sided shape whose corners are on the edge of a circle, and in that case, opposite angles add to 180. So x plus 120 must be 180. X therefore must be 180. Take away 120, which is equal to 60 degrees. And state the rule is to do with cyclic quadrilaterals, quads. Okay, in the diagram, BA and BC are two tangents to the circle. Work out the angle y. So we're asked to work out this angle here. Now, these are two tangents. You know when a tangent, this is a radius because it comes from the centre. This is a radius. When a tangent meets a radius, they meet at 90. And similarly here. Okay? Right. Also, you know, this angle here, which I'm going to call AOC, angle AOC is double the angle at the edge. So it must be 2 times 58, which is equal to 116. So this angle here is 116 degrees. Now consider, I'll draw in green, you've got a quadrilateral here, right? So that's 116, that's 90, that's 90. This here is two lots of y, it's y plus y. So therefore, these angles must add to 360. So 2y must be 360. Okay, take away 90, take away 90, take away 116. Which should be 64. So therefore 1y must be half that, which is 32 degrees. And that is your answer, 32 degrees. And 18 part C, the diagram shows a circle with centre O and tangent at T. Write down the value of angle x. Well, you should know when a tangent meets a chord, the alternate segment theorem is in play. This angle would be the opposite angle in the shape form. So x must be 70 degrees, and the reason you just state alternate segment theorem. And it's as simple as that. Okay, question 19. Connor has 3 oak trees in his garden. He measures the height and diameter of the shortest tree, the results are shown. Its height is 1.65 and its diameter is 0.1. Connor knows the height of the tree is directly proportional to the square of the diameter. Work out an equation connecting h, the height, and d, the diameter. Now, let's read it. The height, h, is directly equals k, some constant k, proportional to the square of the diameter. It's proportional to k multiplied by d squared. Okay, so, or simplifying, h is equal to k d squared. Now, you know some facts here. You know if you substitute in 1.65, the height, and d is 0.1, you can work out k. K, therefore, must be 1.65 divided by 0.1 all squared. So 1.65 divided by 0.1 squared is equal to 165. K is therefore 165. So you can rewrite this formula with k in it. H is therefore equal to 165 d squared. And you have your formula. Connor wants to know the height of the tallest tree. He measures the diameter and gets 0.25, work out the height. You know the height is equal to 165 d squared, so therefore the height must be 165 multiplied by 0.25 squared. And when you do that calculation, you get 10.3 meters to 1 dp. Simple, simple, simple. Okay, question 20. The diagram show how guttering is joined together. Joints are exactly 25 centimeters long. So here's a gutter, and you put a joint on as follows. You join the two gutters with a joint between them. Gutters and joints overlap by exactly 8 centimeters on each side. So you've got this length of gutter, and the joint connects them together, and it overlaps the gutter on the left hand side by A, overlaps the gutter on the right hand side by A. The total length of the joint is 25, so therefore the bit where there's no gutters in between is 9 centimeters. A roof measures 18 meters to the nearest 10 centimeters. Pieces of guttering measure 6 meters to the nearest 10 centimeters. Will 3 pieces of guttering and 2 joints be enough to make a piece to fit the length of the roof? Show your working. Okay, to start with, let's draw a picture. The roof measures 18 meters, so I'm going to do that as the roof. And I'm going to say that measures 18 meters. Let's just make the question into a picture before we start dealing with the issues of the question. Then pieces of guttering measure 6 meters to the nearest 10 centimeters. So you want 3 pieces of guttering there. You'd have guttering here, and guttering here. Okay, if you had 3. Now you know that's 6 meters. That's 6 meters. That's 6 meters. Now the reason I've left a gap between them is from the question. Remember that there's always a gap of 9 centimeters between 2 gutters there. There's always a gap of 9 centimeters. So here, this gap here is 9 centimeters. This gap here is 9 centimeters. Okay, now, can you be absolutely certain that these 3 will cover that? Now, it seems like it would be the case, but the key here is about upper and lower bounds. Can you be certain? The roof measures 18 meters to the nearest 10 centimeters. Okay, so you know what could the roof be at its maximum? So the upper bound of roof at its maximum would be 18 meters plus half of this. Half of the 10 centimeters would be 5 centimeters. It would be 18 meters and 5 centimeters, which I would say is 1805 centimeters. The upper bound of the roof, okay? So that's the most it could be. Now imagine we know that the pieces of guttering are 6 meters to the nearest 10. What if these were the smallest ones that you found in the shop? So what if you pick the lower bound of these, of the guttering? Now that would be 6 meters take away 5 centimeters, which would be 595 centimeters, and there's 3 of them, okay? So it'd be 595 times 3, which would be 1785. Okay, but then you would have to add the 2 9s. So you'd have to add 18 centimeters to this, and you would get 1803 centimeters. So the answer, therefore, is you cannot tell. Okay, it may be enough, but if roof was maximum and guttering was min, you would be 2 centimeters short. Okay, so you can't tell. In some cases it might work, but just say if your roof, you know it's 18 to the nearest 10 centimeters, what if it was 1,805 centimeters, and these were the shortest ones that you could get, so they were 595 centimeters, 595 centimeters, 595 centimeters, with the 9 and the 9, then it would not be enough. So you can't tell. Okay, question 21. OAB is a triangle. OA is 2A, the vector. OB is 3B. M is a point on AB, such that OM is 4/3 A plus B, so this vector here. Compare the lengths of AM plus AB. So before you go for lengths, let's just write the vector that gets you from A to M. Okay, so let's do this one. How do you get from A to M? Well, you go down this way, so you go negative 2A, and then you go up this way, so you go plus 4/3 A plus B. Now combine that, negative 2A plus 4/3 A, or negative 2 plus 4/3 is negative 2/3 A, so this is negative 2/3 A plus B, right? So A to M is that. Let's change a different colour pen. Now we're going from M to B. How do you get from M to B? So you go down here, so from M to B, you go negative 4A over 3, negative B, and then you go plus 3B, right? And combine that, negative 4/3 A plus 2B. Okay, now let's look at them in isolation. Let's look at this one, and let's look at this one. Can you see that MB is twice this one? Because if you double this, yeah, you get negative 4/3 A plus 2B. So therefore AM, the vector AM, twice the vector AM is equal to the vector MB. Therefore, AM is half of MB, or MB is double AM. So MB is 2 lots of AM. And you're done for 5 marks. Okay, next question. The histogram shows information about the age of 73 snooker players, so you know the total adds up to 73. Estimate the number of players who are older than 32. Okay, right, for 3 marks here, let's firstly just work out the frequencies. This is, you know that the area is equal to the frequency on a histogram. So this here would be 5, because it's 5 times 1. This here would be 5 times 2.5, sorry, it would be, it's not 5, it's 6 times 2.5, which is equal to 15. This one here would be 4 times 2, which is 8. This one here would be 1.5, it would be 15, 10 times 1.5. And this here, this looks like 15 times 2, which is 30. Let's just double check they all add up. 5 plus 15 plus 8 plus 15 plus 30, it adds up to 73 as we go. Good, so we've done that right. The number of players who are older than 32. Well, let's look at the 32 bar. I'm just going to draw a picture here to represent the 32 bar. 30 to 40, and you know this is 1.5 high. Okay, now 32 must be one of the squares across. That would be 32. So you want people who are older than 32. So you want to work out how much is this side plus this number here. So this side here, if that's 32, the rest of the bar is, that's 1/5 of the whole rectangle. This must be 4/5. So therefore you want 4/5 of the total bar. So you want 4/5 of 15 plus 30. 4/5 of 15 is 12 plus 30, and 12 plus 30 is 42. So 42 is a good estimate. Question 23a, expand and simplify the following. You must get questions like this right. You know, if you're struggling for marks on a paper and you think you can't go to the end, look at these for 2 easy marks here. X times x is x squared, x times -3 is -3x, 1 times x is 1x, 1 times -3 is -3. Combine these two and you get x squared, subtract 2x, subtract 3. Okay, last question here. Let's see if we can get this right. This is 6 marker. The diagram shows a rectangle and a square. Here's your rectangle, here's your square. Their perimeters are equal. The area of the rectangle is 12 centimeters squares. Use an algebraic method to find out x. Now, let's just do something very straightforward here. If that's x plus 1, then that's x plus 1, right? And also, if that's x minus 1, then this is a square. That's x minus 1, that's x minus 1, and that's x minus 1. So, you know the perimeters are equal as well, right? So you know the perimeter of the square is 4 lots of this. Must be 4 times x minus 1, which is 4x subtract 4, right? That's the perimeter. Now, you don't know this length here. I'm going to call that y, and you don't know that length y, but you know that these must add up to the same thing as this because the perimeters are equal, okay? So, what you can say is, you could say that 2 lots of these, so 2 lots of x plus 1 plus 2 lots of y, must be equal to this, 4x subtract 4. Times that out, 2x plus 2 plus 2y is equal to 4x subtract 4. Take away 2x from both sides, take away 2. 2y must be 2x, subtract 6, so 1y must be x subtract 3. So therefore, this here actually must be x subtract 3. And let's just double check that works, we haven't made a mistake. If you add these up, you get 4x minus 4, which is the same as this. Okay, so therefore we have got this here. Now the next thing you're told, the area of the rectangle is 12 centimeters, is 12 square centimeters. So x plus 1, the width, times the height, which is x subtract 3, must be 12. Oh look, this is quite familiar. You expanded that out in part A, x plus 1, x minus 3. And it expands out to x squared, subtract 2x, subtract 3 is 12, right? Now, you can't solve a quadratic till one side is 0. So take 12 off both sides. X squared, subtract 2x, subtract 15 is 0. Now you want to factorise 2 numbers that multiply to -15 and add to -2. Well, -5 and +3 do. So x subtract 5, x plus 3 is 0. And therefore this is 0, this is 0. So x minus 5 is 0, or x plus 3 is 0. So x is 5, or x is -3. Now, you ignore this one. X can't be -3, can it? Because if it were, then this would be a negative length, and you can't have that. So x is 5 is the only possible answer. Then check everything you did worked. If x was 5, and this was the square would be 4, 4, 4, and 4, and its perimeter would be 16. If this was x, then this would be 6, 6, 3, and 3, and they add up again to sorry, that would be 2 and 2. These again would add up to 16, and the area of this would be 12 centimetres squared. So you know you've got the right answer for 6 marks and you're done. Okay, so thank you for watching the video. I hope you found it useful in your revision.